Hello everyone, and welcome back to another video on Haskell. Today we are going to take a short break from our series of syntax and functions, and instead we're going over probably the most important concept you can learn in Haskell, as well as a very useful concept in programming and computer science, and problem solving using programming in general. Today we're going to go over recursion. So recursion essentially just means self-referencing. So when we're writing a recursive function, we want to write a function that calls itself. If that sounds confusing, let's use a math example to go over, hammer in what recursion is to begin with. And we're going to use the example of the Fibonacci sequence of numbers, which is as follows: 0, 1, 1, 2, 3, 5, 8, 13, 21, and so forth. The Fibonacci sequence is defined such as the first number in the Fibonacci sequence is 0, the second number of the sequence is 1, and every following number in the Fibonacci sequence is defined as the sum of the two previous elements. So for the third number, we want to add the first and second number. 0 plus 1, that's 1. For the fourth number, we want to add the third and the second number. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5, and so on and so forth. This is an example of a recursive sequence of numbers, where we have the first values defined. The first and the second are defined, like statically defined. The first is 0, the second is 1. And every following element is defined as the sum of the two previous values. So we're going to implement a function that takes an integer as its argument and returns the nth number in the Fibonacci sequence using precisely this definition. So for our type definition here, for our Fibonacci function, we're going to take as we said, an integer as an argument and return an integer. So first off, when we're working with the recursion, we want to define a base case. Just like with the Fibonacci sequence of numbers, the first two elements are statically defined, where the first element is 0, the second is 1. So we want to define that here as well. And we can do that very easily with pattern matching, which we went over in the last video. We simply pattern match it to Fibonacci of, let's call it 0 equals 0, and Fibonacci 1 equals 1. And then, as we went through, the nth number in the sequence is defined by the sum of the two previous numbers of the sequence. So for any other n, we define that as Fibonacci n minus 1 plus Fibonacci n minus 2. Now let's save this, load up our compiler, and try it out. Fibonacci 1 gives back 1, just as we would expect, since we've pattern matched it to that. Fibonacci 2 also gives us 1, since 1 is the sum of the previous two numbers, 0 and 1. Fibonacci 3, 2, fourth number is 3, fifth is 5, 8, 13, 21, and so forth. Another useful way you can implement a recursive function in Haskell is when you're working with lists in really any way you want to. So let's say we want a function that takes an integer argument as well as a list of integers and multiplies every integer in that list with our input argument. So we want an integer argument and a integer list argument and turn that into a list of integers. Again, when we're working recursively, we're going to need a base case. When we're working with lists, that's typically going to be our empty list. So when we have any integer value here and an empty list, that will just return an empty list. Because it doesn't matter what number n we have here. If you multiply it by an empty list, it's still an empty list, you see. And for any other case, you have an n here, and like we went over last time, you can define a list like this, so that x is our head and xs is the rest of the list. This way of defining a list in our arguments of a function is very useful, because then we can do like this. So we want to add n times our x to our mult list n followed by xs. Let's put this in parentheses for clarity's sake. So this function here will do the same thing. It will work, first it will work on the head of the list and add it to the remaining list. It will call the function on the remaining list, where it will take out the head of that list, apply the functionality, in this case n times the head, and add it to the next recursive step, where we'll take the list without the two first elements and apply the function again, and so forth until it gets to our base case, where it then will wrap it all up and return our list the way we want to. So let's quickly define a list here. Go to list of integers. List is the first 10 positive numbers, let's say. Save it, reload the file, alt list 2 and our list. And you can see we've doubled every element in our list of the positive integers between 1 and 10. Let's try it with another number, 3. You can use a recursive function to add elements in a list. Let's say we have a list of integers and want to return their sum. There's a built-in function for this already, but this is how we can make our own such function. Again, define our base case. When we're working with lists, that's typically going to be our empty list. So define a base case as an empty list, which will return 0. And for every other list, x merge with xs will return x plus add list xs, like that. Reload. Let's try that function on our list here. It returns 55, which is the sum of all integers 1 through 10. This has been an introduction to recursive functions in Haskell. There are a multitude of different ways you can implement a recursive function. We're definitely going to go over more of them in later videos, but I hope this has given you an idea of how recursion works in Haskell. Thank you very much for watching.